Section 8.2, Naming Molecules. The objectives of this lesson are to translate molecular formulas into binary molecular compound names and name acidic solutions. Some vocabulary to review is oxyanion, and some new vocabulary will be oxyacid. Many molecular compounds have common names, but they also have scientific names that reveal their composition. To write the formulas and names of molecules, you will use processes similar to those described in Chapter 7 for ionic compounds. Start with a binary molecular compound. Note that a binary molecular compound is composed of two nonmetal atoms, not metal atoms or ions. An example is dinitrogen monoxide, a gaseous anesthetic that is most commonly known as nitrous oxide or laughing gas. The name of nitrous oxide is explained in the following rules. The first element in the formula is always named first, using the entire element name. N is the symbol for nitrogen. The second element in the formula is named using its root and adding the suffix IDE or "ide". Oxygen is the symbol, O is the symbol for oxygen, so the second word is oxide. Prefixes are used to indicate the number of atoms of each element that are present in the compound. Table 8.3 lists the most common prefixes used. There are 2 atoms of nitrogen and 1 atom of oxygen. So the first word is dinitrogen and the second word is monoxide. There are exceptions to using the prefixes shown in 8.3. The first element in the compound name never uses the mono prefix. For example, carbon monoxide, not monocarbon monoxide. Also, if using a prefix results in 2 consecutive values, one of the values is usually dropped to avoid an awkward pronunciation. For example, notice the oxygen atom in carbon monoxide is not monooxide. And in 8.3, we kind of have a list of them. Some of these are probably pretty familiar with you, right? Mono, di, tri, like triangles for 3 sides. Tetris has 4 little blocks. Penta, like a pentagon. Hexa, hepta, octa, like an octopus, has 8 tentacles. Nona and deca, right? There are 10 years in a decade. Let's go ahead and name the compound P2O5, which is usually as a drying and dehydrating agent. You're given the formula for a compound, and the formula contains the elements and the number of atoms of each element in one molecule of the compound. Because only 2 different elements are present and both are nonmetals, the compound can be named using the rules by naming binary molecular compounds. First, name the elements involved in the compound. Phosphorus. The first element represents the P, which is phosphorus, and then oxide, because there is oxygen involved. All right, so we have something that looks like phosphorus oxide. All right, now we're going to go ahead and look at how many of each of these we have. Because we have 2 phosphorus in the compound and 5 oxygens, we're going to go ahead and put a di, which is the prefix for 2, in front of the phosphorus. And then we're going to go ahead and put the prefix penta in front of the oxide. And again, this is one of those instances where we're going to go ahead and drop the A from penta and just call it pentoxide, just to kind of avoid that awkwardness in pronunciation. All right. If you want to go ahead and try these examples, pause the video and I'll give you a minute to work on them. All right, this compound is called carbon dioxide. 15 is called sulfur dioxide. 16 is called nitrogen trifluoride, and 17 is carbon tetrachloride. Have you ever enjoyed an icy cold glass of dihydrogen monoxide on a hot day? You probably have, but you're most likely called it by its common name, water. Recall from Chapter 7 that many ionic compounds have common names in addition to their scientific ones. For example, baking soda is sodium hydrogen carbonate, and table salt is sodium chloride. Many molecular compounds, such as nitrous oxide and water, were discovered and given common names long before the present-day naming system was developed. Other binary covalent compounds that are generally known by their common names rather than their scientific names are ammonia, hydrazine, and nitric oxide. Water solutions of some molecules are acidic and are named as acids. Acids are important compounds with specific properties and will be discussed at length in Chapter 18. If a compound produces hydrogen ions, which is H+, in solution, it is known as an acid. For example, HCl produces hydrogen ions in solution and is an acid. Two types of common acids exist: binary acids and oxyacids. A binary acid contains hydrogen and one other element. The naming of common binary acid, known as hydrochloric acid, is explained in the following rules. The first word has the prefix hydro to the name of the hydrogen part of the compound. The rest of the first word consists of a form of the root of the second element plus the suffix "ic." HCl, hydrogen and chlorine, becomes hydrochloric. The second word is always acid. Thus, HCl in a water solution is called hydrochloric acid. Although the term binary indicates exactly two elements, a few acids that contain more than two elements are named according to the rules of binary acids. If no oxygen is present in the formula for the acidic compound, the acid is named in the same way a binary acid, except that the root of the second part of the name is the root of the polyatomic ion that the acid contains. For example, HCN, which is composed of hydrogen and the cyanide ion, is known as hydrocyanic acid in solution. An acid that contains both a hydrogen atom and an oxyanion is referred to as an oxyacid. Recall from Chapter 7 that an oxyanion is a polyatomic ion containing one or more oxygen atoms. The following rules explain the naming of nitric acid, HNO3, and oxyacid. First, identify the oxyanion present. The first word of an oxyacid's name consists of the root of the oxyanion and the prefix per or hypo if it is part of the name, and a suffix. If the oxyanion name ends with the suffix ate, replace it with the suffix ic. If the name of the oxyanion ends with the suffix ite, replace that suffix with us. Now, a way I like to remember is that, ate is great and terrific. Right, so if we were to go ahead and look at the nitrate ion, right, nitrate, right, because it ends in ate, would get that suffix ic. Now the second word of the name is always acid. So here we had nitric, now we added the hydrogen to it, right, and it becomes nitric acid. Right. 8.4 shows the names of several oxyacids following these rules. Here is our chlorate anion, right? Because it ends in ate, it's going to get that suffix ic, and it becomes chloric acid. Right? Same thing with chlorite, it ends in ite, so it gets that OUS, us, and it becomes chlorous acid. And again, we can say perchloric acid or even hypochlorous acid. You've learned that naming compounds follows different sets of rules depending on the composition of the compound. Now just note, please do not confuse these rules with the rules of naming ionic and metallic compounds. Right? When we're dealing with nonmetals, right, nonmetals and nonmetals, we follow the covalent rules. If we're dealing with a metal and a nonmetal, we follow the ionic and metallic rules. So table 8.5 summarizes the formulas and names of several covalent compounds. Note that an acid, whether a binary acid or an oxyacid, can have a common name in addition to its compound name. Right? Such as water is known as dihydrogen monoxide, ammonia is nitrogen trihydride, etc., etc. So let's go ahead and try and name these compounds here. All right, go ahead and pause the video, and we can go ahead and name these following acids. Number 19 is hydroiodic acid. Number 20 is chloric acid. Number 21 looks like chlorous acid. Number 22 looks like sulfuric acid. And number 23 looks like hydrosulfuric acid. The name of a molecular compound reveals its composition and is important in communicating the nature of the compound. Given the name of any binary molecule, you should be able to write the correct chemical formula. The prefixes used in a name indicate the exact number of each atom present in the molecule and determine the subscripts used in the formula. If you are having trouble writing formulas from the name of binary compounds, you might want to review the naming rules listed on pages at the beginning of this section. The formula for an acid can be derived from the name. It is helpful to remember that all binary acids contain hydrogen and one other element. For oxyacids, acids containing oxyanions, you will need to know the names of the common oxyanions. If you need to review the oxyanion names, go back to chapter 7 and look at table 7.9 for your common polyatomics. Right. Go ahead and practice these problems based on the name. So pause the video and give these a try. So the formula for 25 would be AgCl. The 26 should be, I think that should read dihydrogen monoxide, right, which would be H2O. 27 would be ClF3. Number 28 would be P2O3. And then strontium acetate would be, this is testing my knowledge right here, SRC2H3O, all in parentheses 2. I could be mistaken on that one. here's a little flow chart of how you can go ahead and name these molecules. Right, look at the formula. Ask yourself, does it create an acidic in solution? Right, if it does, go left. If it doesn't, go right. And if it has mono, only one other atom, right, it'll go ahead with that root of hydro and ic acid. But if it contains an oxyanion, it will go with that ic or us followed by acid. Again, this flowchart can help you determine the name of a molecular covalent compound. To use the chart, start at the top and work downward by reading the text contained in the colored boxes and applying it to the formula of the compound you wish to name. Section summary. Names of covalent molecular compounds include prefixes for the number of each atom present. The final letter of the prefix is dropped if the element name begins with a vowel. Molecules that produce hydrogen ions in solution are acids. Binary acids contain hydrogen and one other element, and oxyacids contain hydrogen and an oxyanion.